Hi everyone, today I'm going to go through the process of gastrulation. The gastrulation process is quite a key process in the development of a fetus, as it is essentially the first glimpse we essentially get into the formation of the actual baby. Gastrulation first starts with the process of a bilaminar disc being present. So if we roughly draw the embryo here, we firstly have a two-layered disc. Now this two-layered disc contains of two main layers. The first layer is the epiblast, and the second is the hypoblast. Now if we're looking at the embryo from a caudal, which means towards the feet, to cranial, towards the head, viewpoint, we will eventually see the formation of what is called a primitive node. And this primitive node is what originates from what we call a primitive groove. So the node is present over here, and this entire structure, which I'll just faintly outline, is called the primitive groove. And so this primitive groove is essentially the first part of gastrulation. And what happens is that the cells that are present within this epiblast layer will now start to move upwards and into the primitive groove. So if I redraw the embryo here, after some sort of movement has taken place by the epiblast cells, it'll look like something like this. This is because the epiblast cells have now started to move inwards towards the primitive groove. So essentially, there will be a layer looking like this and a layer looking like this. This is because the hypoblast has stayed in its own position, it hasn't moved, and the epiblast has started to move inwards towards, in a cranial direction, towards the towards the primitive groove, and therefore has allowed for this flexing. Now these epiblast cells are what we call invaginating. And in the process, what happens is that some cells are able to slip into the space between the epiblast and the hypoblast, which is this space here. Now this space is quite important because it's essentially the middle ground between the epiblast and the hypoblast, and the movement of these cells from the epiblast to the hypoblast essentially means that the cells of the epiblast can start to replace the cells of the hypoblast. Eventually, if we redraw the embryo here, the hypoblast will turn into what we call the definitive endoderm. The definitive endoderm is one of the first, or as you can say, the most caudal germ layer, and it allows for the formation of many different tubes around the body, such as the digestive tract, the respiratory tract, epithelium of urogenital organs, among other things. So now this layer is no longer called the hypoblast, but is rather called the definitive endoderm. And of course, we still have the epiblast here, with its cells moving into this space as this process is occurring. Now, what happens next? So, once all of these cells of the definitive endoderm have been replaced, now there is no way or nowhere for the cells of the epiblast to move anywhere. So essentially, these processes stop occurring and cells no longer move into this area. Instead, the cells that have already moved into this area and are simply unable to move back into the the epiblast, form a new germ layer. This germ layer is called the mesoderm. The mesoderm is also another very important germ layer, as it allows for the formation of many things, including urogenital organs, some dermis, it allows for the formation of the dermis, and also many other parts of the body. Finally, now that epiblast cells have moved from the epiblast to the hypoblast, replacing it and forming the definitive endoderm, and some cells have also formed the mesoderm, the epiblast is no longer traditionally what we call the epiblast, and therefore this space now is now called the ectoderm. So it's no longer called the epiblast, but now is called the ectoderm. And the ectoderm is also a very important part, or also a very important germ layer, as it allows for the coding of parts of the body, such as the nervous system, epithelium, such as hair and skin and nails, and also many other parts, such as the epithelium of the oral cavity, nasal cavity, and as well as the epithelium of the pituitary gland. So now that the replacement of the hypoblast, the formation of the mesoderm, and the formation of the ectoderm has taken place, the process of gastrulation is complete. So the embryo will look something like this now. So it will still retain its circular shape. Now that invagination has occurred, there will be no more further movement towards the neural groove or the primitive streak. So this will remain as so. Then there will be a germ layer beneath it called the ectoderm, then another one beneath it called the mesoderm, and finally another one beneath it called the endoderm, finally leading off with the cavity at the bottom. So this is the ectoderm, mesoderm, and endoderm. Thus, the process of gastrulation is now complete.